Hi, so in this video we're going to be importing and setting up the roughing operations on this workpiece. So we're going to the model space and we're going to import the file. We'll just go through the standard checks to make sure it's all placed properly. So locate 0, middle, min, apply, move it up 50 millimeters in Z. Oh, 50, not 500. Apply and close. And now we're going to the machining environment, and we can see it's automatically placed itself on the small table in this environment. I'm going to switch around to this view here just because it's generally easiest to work out what's going on from here. This model file and this robot cell will be available for independent download in the comments section of this video. So beyond this point we need to define the workpiece. So I'm going to set this to be a primitive box around the part with 5 millimeters of excess in each plane, except for in negative Z, because we've got no way of machining under this, because the whole purpose of this series of videos is to utilize the basic 3D functionality. So the robot will be operating in much the same manner as a traditional 3D mill will in this instance. So add and close. Right. Now, one of the things that we can do to define the orientation and management of the robot to try and limit any future problems, instead of defining the tool orientation for each and every operation, if we set the 6th axis control to a fixed vector, this means that the orientation of the 6th axis will stay locked in that Z orientation. So we won't have to deal with defining tool orientation or axial approach for each and every operation, hopefully. We'll also set the links to avoid collisions because although there's not a lot of very complicated high-sided topology in this model, it is generally the best approach philosophy for this particular style of machining as well. So now that that's done, we can define our first operation. And I'd like to change the way that we work in this slightly. Since we're emulating a 3D milling process, we're going to be using a lot of setups in this, not to their fullest extent. In the case of a standard milling application, you can use setups to define different layouts of the workpiece and everything. For this, it's purely just to make sorting through our operations a bit simpler and a bit easier to remember. So I'm going to go to structure and add a setup stage, which we are going to rename, and you can do this by right-clicking and selecting rename or just pressing Ctrl R. And we're going to call this the roughing. Just call that roughing for now. And the first operation we're going to add is going to be a 3D entry face milling operation. Now we can see that it's automatically lost the 6th axis control orientation, which is not ideal, but it's an easy fix as opposed to having to go through the full traditional system. Now, if we set in parameters, we want the tolerance to be a little bit looser than that, just for the sake of a faster calculation. So we're going to press 0.02. I'm going to turn off check for plunges because I found with this job in particular, we get a lot of iterative complaints about plunges that don't actually affect the final outcome in the slightest. So I'm just going to default to turning that off for the moment. And under strategy, we can see these levels that we've got here. So 92.129 corresponds to the very, very top of the material. 87.129 corresponds to the top of the actual object. So I'm going to increase that slightly to give us a little bit of extra material to work with in later operations. So I'm going to type in 88 millimeters here, and we're going to try generating a toolpath. And as we can see, there are some parts that it can't reach in its current orientation because it doesn't quite know how to, and we've got some very strange links and leads coming in here. So if we now go into the axis map, we should be able to see the culprit for this problem. And as I suspected, we have a lot of out of limits issues, specifically centering around the 0 degrees deflection point here. This is due to the fact that in, I suppose, what you could call a zero position for a robot, because it's so close to a series of fixed parameters, it can hit a singularity very quickly and it can effectively lock itself up. So we need to deflect it from this very slightly just to be able to give it the best chance of calculating. It's one of those situations where the kind of thing that a much simpler machine can do with great ease a robot struggles with. Obviously, these particular instances are relatively few and far between, but you do need to be aware of them. So if we click on Build Map now, and then Build Graph, and then we update the toolpath accordingly, we can see how there's been that alteration in angle for the 6th axis orientation, but we've now got a completely clear toolpath here. So that means that we've now got a perfect spiral toolpath that will clear up the first pass of the material for it, which is great. So the next thing that we're going to do now, sorry, just adjust the zoom slightly, is we're also going to set up a roughing waterline path. So we go to the Add Operation menu, and under 3D Entry, we go for roughing waterline. Now, this 80mm tool is going to be too large to really get into a lot of this, so I'm going to adjust the parameters of that slightly. Obviously, when you're setting up a job like this yourself for the real world, you'll have a list of tools available to you that will be in your tool table. Because this is purely hypothetical, I'm going to invent a couple of standard tools that we'll use throughout this. So we're going to go with a 20mm diameter and say a 60mm length. So it's still quite a chunky tool, should be good and solid. We'll press Apply Changes and create a new tool. So that's great. And we need to define that 6th axis control. Okay, looks like I got that wrong at the very beginning. We also need to define where we want this to actually go on. So I'm going to tell it that I want it to be able to do all of the waterline roughing inside this region. And the easiest way to do this is to be able to grab one of these edge lines and then just tell it to chain all around. So I'm going to turn on Select Edges. I'm going to double click on that and you can see how it's automatically grabbed the entire chain. 9 times out of 10 this will behave exactly as you hope it will do. However, sometimes when you're dealing with more complicated topologies, the chain won't necessarily follow the order that you initially expect. So as with every other kind of 3D selection tool, you can still use Shift and Control to select and deselect individual parts as well. So I'm going to set that as the job zone. I'm now going to define this as the top level and this as the bottom level. And from here, I am going to generate the toolpath. And we should see the same issue again where it can't reach everything. So we'll go back into the axis map. Now, there we go. Now, fortunately, due to the relative simplicity of the part that we're working on, axis mapping is not an incredibly long and painful process. Although when the toolpathing starts to get more detailed and intricate, this will slow down significantly. So I will be pausing for the duration of those just to save you from spending 10 minutes watching not much. So again, we have all of these difficulties around the 0 point on the 6th axis, so we need to deflect a bit from that, which is fine. So build the graph, update the toolpath, and now we have this lovely clear roughing area. And I suspect that this complaint here is it's about a plunge move. So again, we're not really super worried about these at the moment. The plunging approach is generally fine. The tool will be spinning fast enough to be able to accommodate a simple plunge. So I'm going to turn off check for plunges for the moment, just to keep these clear. I'm aware of it in the back of my mind, and obviously when prototyping a toolpath like this, the first thing you do is you do check with a very, very slow dry run. But yeah. So for now, we're just going to simulate what we've got, and since we're using solid body simulation on this, we should get a much more accurate read of what the final cutting is going to look like, as opposed to using, say, the voxel simulation, which is much better for things like sculptural elements, but when it comes to hard material machining like this, solid body is significantly more accurate. And something that I have just noticed, which I hadn't set in this, is I haven't given myself any kind of stock allowances here. So again, I'm going to set this to 0.2 for speed. I'm going to add a millimeter radial and a millimeter axial stock, just so the finishing passes actually have something to do. And that should regenerate with the same parameters it had before, so we should be good there. We'll just double check the axis map just to be certainly sure. As we can see, it's extended a little bit there, but we've not got any surprises. So we'll break that calculation, build the map, update, and now we can simulate just to make sure that our part is good. So I'm going to zoom back out and then come in a little bit closer, and we'll speed up the simulation. And we are going to be stopping and simulating multiple times throughout the setup of this, because realistically, it is the kind of job that needs a lot of checking throughout. So we'll run this now, and that's our initial facing path. That's good. And we've now got our waterline roughing, which is nice. Seems to be going well with no complaints so far, which is exactly what we're after. We now have nice green node statuses throughout. Obviously, the fact that we turned off plunge detection will affect that, but you know, that's a relatively minor thing, and something that, since we're aware of it, it becomes less of a problem. I'll see you in the next video, where we start setting up our first cleanup processes, and then we're going to start moving into finishing and surfacing at a later point. See you then.